Welcome to Highline Excel class number 47. Hey, if you want to download this workbook and follow along, click on my YouTube channel, then click on my college website link, and you can download the workbook, Week 9, Business 214. Hey, if you're enrolled in the class, just go to our Chapter 9 website. Hey, Chapter 9, we're going to talk about finance. And we're going to start it off by talking about the payment function, the PMT. Now, what does the payment function do? Well, how about loans? We have a car, a down payment, and we have to borrow the rest. And the PMT function will allow us to easily calculate the monthly payments for an amortized loan. Let's start off by doing our calculation for loan amount equals whatever we paid for the car minus the down payment. Now we have to come over here and we're given an annual rate and we need to convert it to monthly rate. Now I'm going to use this 12 here because earlier in this class and other videos I've done, we talk about monthly payments, but it doesn't have to be 12. It could be quarterly, or for bonds it could be semi-annual, twice a year. So we're going to do our formula equals the annual rate divided by our number of periods per year. Similarly, our total periods, or NPER, total months, is going to be our years times our periods per year. That way, if we change this to 6, everything updates. I'm going to Control Z. Now, we'll go ahead and calculate our payment. We need to figure out whether our payment is at the end of each period or the begin of each period. An annuity due or a regular annuity. Most of them are going to be end, and so the PMT function, you can type in the last argument 0 or leave it blank. For our first example, we have a monthly payment where we pay it at the end of each month. Equals, and we'll use the PMT function. Now, the important thing about the finance functions is that you have the right period. So when it says rate, it doesn't want the annual rate. If we're calculating monthly payments for our PMT, then the rate needs to be a monthly rate. So we'll click on that. Comma, similarly, NPER, total number of periods, has to be our total number of periods. Comma, and our present value. Now, these financial functions, PMT, future value, present value, some other ones we'll see, rate. Cash flows matter. So we always have to think what direction the cash is going. When you go out and borrow $24,799, the moment you borrow it, it's coming into your pocket. Even though 1 second later you give it to the car dealer, still, when you borrow it, you're borrowing it from the bank. So from your point of view, it's coming from the bank to you, so it is a plus. So I'm going to click right there. Now, future value is for balloon payments at the end, and type, we could put a 0. If we wanted to do that, we'd have to put comma to skip the future value because we don't have a balloon payment, and then comma to get to the type. But forget it. We don't need to do that because by default it assumes payment is at the end. So we can close parentheses and then enter. So there we have it. If you look right here, I have the math formula. So isn't that lovely? That's our annuity formula. Isn't it much nicer to not have to do that and simply have the payment? The payment function is programmed to do exactly what this big math formula is doing. Now let's do the same thing. And notice, very important, the payment is negative. That means every month when you take out your wallet and the cash goes flying to the bank, that means it's a minus from your wallet or purse. So that's why it's minus. Cash flows matter. When we borrow the money, it's into our pocket. When we pay it, the monthly installments back to the bank, it's $24,000. When we borrow it, it's into our pocket. This is out of our pocket. Now let's do one when we have payment at the beginning of the period. So equals PMT. I'm going to get my monthly rate, comma, number of periods, comma, my present value, which is positive because it's coming in, comma, to skip the future value because we don't have a balloon payment, comma, and then the type, I'm going to click right there. So 1. That means annuity due. That means our first payment is due right the moment we take out the loan. And we can see it's a little bit lower because we're paying some extra money up front. So less interest is paid out during the life of the loan. Let's go on to our next example. It's the same example as this one, 485.22. But this was from the borrower's point of view, right? Minus 485. That's how much comes out of our wallet each month. Let's do the same problem from the borrowers. I'm sorry, from the lenders. Here's the lender, the bank. Equals PMT. The rate is going to be our monthly rate, comma, our number of periods is going to be our total months, comma, our present value. When the bank gives you the $24,799, that's a minus. It's going out of their pocket and into yours. So you have to put a minus here, minus that amount. This is from the lender's point of view. Now, we don't need balloon payment or type. The default is 0 or end, which is what we're doing right here. Yeah, and so enter, and there we have $485.22. And it's positive. In fact, just to make this better looking, let's get rid of that minus. And then let's properly record this one here on the face of the spreadsheet. I'm going to put minus and then open parentheses and then close parentheses. That way we see right on the face of the spreadsheet the point of view of the lender is cash going out of their wallet up front, but this is coming into their wallet each period. That one, this math formula, I'm not going to change that one right here. That one's set up from the point of view of the borrower, not the lender. Actually, we could easily do it by putting in a negation, close parentheses, and then close parentheses at the end. All right, let's do our next PMT. That's 3 examples so far. Now we get to do a balloon payment. So here, price of the car is $50,000, down payment $5,000, loan amount is $45,000, but we have to pay at the very end. The last day, when we give our last payment, we're going to have to also pay $5,000. So we're going to create our formula right here. And this one is at an annual rate of 5.25%. 3-year loan, compounded periods per year, 12. So equals PMT. The rate is going to be our monthly interest rate, comma, NPR is 36. Comma, the present value, since this is from the borrower's point of view, is going to be 45,000, a positive, comma, the future value. That's got to be negative because we're paying it out at the end. So I have recorded it as negative there, comma, and then we don't need type because this is end. We're assuming this is end. Close parentheses and enter. So we're going to be paying $1,225 each period, and then $5,000 at the very end also as a balloon payment. Let's do our final example. We have delayed payments, and this one is periods per year 4. So we have a quarterly payment. Now the only trick, if you go out and you borrow $1 million and the annual rate is 8.5, the period rate, which of course is a formula, is 2.13%, and total periods is 24. We have 6 years, 4 periods per year, 24. The only trick is if you delay payments for 1 year, it's not like they stop collecting interest. They're still going to be collecting interest. They're just going to be adding it to the principal. So we're going to have to look at the function future value. Future value equals FV. Future value will take a certain amount invested on a certain day and tell you how much it is worth given our interest assumptions here at the end of a number of periods. Now for us, we're going to leave it in for 1 year, which means 1 year times the quarters. So for 4 quarters, this $1 million is going to be accumulating interest. Now we could do a formula, a math formula, but the future value function will do it just fine. Our rate is going to be our period rate. Remember, periods, number of periods, when we get to payment, all have to be in the same unit of time, and this is quarter. So the rate is the quarterly rate, comma, the number of periods. Now we've got to be careful here. We have 1 year and 4 periods per year. So for NPER, in case this changed, in case we change this to 2, we're going to say number of years payment is put off times the number of periods per year, which is 4. So that is our NPER, total number of periods for this 1 year, for this future value calculation. Comma, now the payment. Oh, there is none. So when you skip an argument, you type a comma, and it just skips it. The present value, this is from the borrower's point of view, so it is a positive. Click right there. And the type is N, so we can leave that last argument off. And there we have it. We have $87,747.96 has been accumulated even as we have been on vacation from making payments. Now, period payment. So we have our new borrowing amount in essence. Now, on the day that we're going to start making, or the day we're going to start making our calculations, our payment's going to be at the end. So we still don't pay on this exact day, but that's the new loan amount in essence, because we've added all that interest in. Now, if we want to, the borrower's point of view, I'm going to put a minus in front of this, because really this future value did exactly spit out a negative number. Remember, we borrowed a positive, so on this day, the future value function says if you were paying it back now, that is a minus that's coming out of your wallet. But since we're going to actually take this now as the input into our payment function as the actual present value, we're going to put a minus in front of it. Cash flows matter. If you get confused, just take out your wallet and think, is it coming from, if you're the borrower, is it coming into my wallet or out of my wallet? If you're doing the calculation for the lender, same thing. You got to think from their point of view and their wallet. All right, now let's do our PMT. We're trying to figure out our quarterly payment. The rate is still this quarterly payment. Comma. Now, NPER, we got to be careful here again, because let me move this off to the side. We've let 1 year elapse, all the interest in there, so we can't just click on the total number of payments. It's actually 4 minus 1, which is 3. 3 years, I'm sorry, I totally said that wrong. Here's years. So 6 minus 1. Oh, there's 5 years left. So 5 years times our 4 will give us 20. So you ready? We got to do this in parentheses. Years minus, total years minus the year we've accumulated interest into the present value. That's 5. If you were to get confused here, you can highlight it and go F9. Oh yeah, that's 5. Control Z. Now you don't want to just type 5 in, because then if you change this formula input, it'll change here, but it wouldn't change here. So you definitely want to reference that. All right, so we got it. 6 times 1, and then we just times our 4. That gives us our NPER. Comma, our present value. We've already made it positive here because it is. It's coming into our wallet on this particular time. Comma, there is no balloon payment, and we do not need a type because it's at the end. So I'm going to backspace, close parentheses, and there's our PMT. There's the that formula right there is all of it put together. We did it in 2 steps, but you could do it all in 1 step right there. Whoa, minus $67,000 in payment every quarter to pay off that initial loan of $1 million. All right, those are 5 exciting tricks for PMT. When we come back, we'll talk about rate and effect and nominal and some other financial functions. See you next video.